Hi and welcome to the solution video of this an old paper of summer 2012 paper 42. If you like this video, please share with your friends, give it a thumbs up and subscribe to Math United. Question number 1. A block is pulled in a straight line along a horizontal ground. Okay, so this is the horizontal ground and suppose this is the block. It is pulled by a force of constant magnitude acting at an angle of 60 degrees above horizontal. So this is, let's say that is force F and this is 60 degrees. Okay. The work done by the force is moving the block a distance of 5 meter is 65 joules. So distance is 5 meter and work done by applied force is 75 joules. Find the magnitude of the force. So what is F? So straightforward, we know that the work done by any applied force is equal to that applied force multiplied by the distance it moved multiplied by the angle, cos of the angle between the force and the motion. Force is in this direction, motion is in this direction, and the angle between them is 60 degrees, so it will be cos 60 degrees. So we'll just replace the values now. 75 joules is equal to force applied F, distance is 5 meters, and cos 60 degrees. So F is the only one unknown here. We can write that F is equal to 75 divided by 5 and cos 60 is half. So you can write 0.5 here. So 5 times 5 is 5 times 0.5 is 2.5. So it will be 30. F will be 30 newtons. Done. That's short of a question and solution. Question number 2. 3 coplanar forces of magnitude F, 12 and 15 Newton are in equilibrium. That's important. They are in equilibrium acting at a point P, okay, in the direction shown in the diagram, and find alpha the angle and F the force. The problem here is that there is no angle given, only alpha is the variable angle here, and we know these two forces only. So this may create a little problem. So what I will do here, I'll do something smart. So what I'll do, I will just name the x and y components differently in this case. So I will say that this is x component and the 90 degree to this, because there's a 90 degree here, right? This will be y component. This will make my job easy. So I don't need to change 12 newtons because it's in y direction, and I don't need to change F newton because it's in x direction. Okay, only 15 newton will be needed to be changed into components. Because alpha is the angle with 15, so this becomes 15 cos alpha, and this will become 15 sin alpha. Okay, no need to change this, no need to change this, they are okay. So since the forces are in equilibrium, this 12 newton has to be equal to this. So 12 is equal to 15 sin alpha. So sin alpha will be equal to 12 divided by 15. So alpha comes out to be sine inverse of, you can cancel them, 4 and 5. Sine inverse 4 over 5. Put this in a calculator and you'll get the angle alpha. By the time I do this, I request you to like this video, share this with your friends, and subscribe to Math United. What I'm getting here is 53.1 degrees. That's the angle alpha. Now I need to know what is F. So I can go in this direction. So F will be 15 cos alpha, yeah, because they are balancing each other here. So F is equal to 15 cos 53.1 degrees, because we know the angle now. Just put this in a calculator and you'll get it. What I'm getting is 9 newtons exactly. Question number 3. A particle P moves in a straight line starting from point O. So let me draw it here. So it is starting from this point O with a velocity 2 meters per second. So here we know that the time is 0, displacement is 0, but velocity is 2 meters per second at this point O when it starts moving. Okay, the acceleration of P at time t seconds after leaving O is this. So acceleration equation is given to us. A is equal to what is it, 2t to the power 2/3 to t to the power 2/3 meters per second square. Okay, first part says show that t to the power 5/3 is equal to 5/6 when velocity not acceleration, velocity of P is 3 meters per second. So first we'll have to convert this acceleration equation into velocity equation, and for that we need to integrate both sides with respect to time. So a dt integration is velocity, and 2 will stay 2, but this will become t to the power 2/3 plus 1 divided by 2/3 plus 1 plus c. Okay, so equation for velocity becomes 2t to the power 5/3 divided by 5/3. Okay, but I will adjust 5 here, and third, denominator of a denominator becomes numerator. So third, 5/3, 5 is here, but third I will write up there, plus c. So v equal to 6/5 t to the power 5/3 plus c. Okay, but nowhere we are near to showing this, but we know t to the power 5/3 we already have here. Somehow if we know c, then we'll get the relation they want, and they have clearly said that P is 3 meters per second at that time. So I will complete it here. At t equal to 0, V is 2 meters per second. So V is 2 meter per second. To get C, I will substitute this thing. So 0 to the power 5/3 plus C. 0 to the power anything but 0 is 0. Okay, so this whole thing is 0. So C is 2. So C becomes 2, and my equation, this one, this final equation, let me write here now. V equal to 6/5 t to the power plus 2. Okay, so this is the equation, and I will use this information now. P is equal to 3. So 3 is equal to 6/5 t to the power 5/3 and plus 2. This plus 2 I'll take to the other side by subtracting 2 here. I'll subtract 2 here also, cancelled. 3 minus 2 is 1, equal to 6/5 t to the power 5/3. Keep t to the power 5/3 here and cross multiply. 5 will multiply with 1 and 6 will multiply with the denominator, which is invisible 1. And voila, that's what they wanted. Yeah, t to the power 5/3 is equal to 5/6. We got it. Okay, part 2 is also there. Okay, find the distance of P from O. P from O, the velocity when the velocity is 3 meters per second. So suppose velocity is here, V is 3 meters per second. What is this distance? Okay, they're saying distance. Hopefully there is no turning point. If there is a turning point in between, then we have to do something else. First, ensure. Let's ensure that there is no turning point. So turning point. And to find turning points, we know that when something turns back, it stops first and then turns back, right? That means the velocity becomes 0 at that turning point. So I'll make this velocity equal to 0 and see if I get any turning point. So 0 equal to 6 over 5 t to the power 5 over 3 plus 2. 2 will again come to the other side, so it becomes minus 2 equal to 6 over 5 t to the power 5 over 3. We know t will always be positive, right? Because time has started from 0. So this is positive, and this positive number can never give you a negative number no matter what is the exponent. That means there is no turning point and we are good to go. We just have to find the displacement, which will actually be distance, because there is no turning point. So for displacement we'll have to integrate this again, right? So let me make some space for this here and find let's integrate that one. So v dt equal to 6 over 5 t to the power 5 third dt plus 2 dt. Okay, let's integrate. Then this is displacement 6 over 5 t to the power 5 third plus 1 divided by 5 third plus 1. Okay, then we'll have here 2t, and there will be another constant, which is, let's call it d. Okay, so s is equal to 6 over 5 times t to the power 5 over 3 plus 1 will be 8 over 3 divided by 8 over 3. The same thing what I did in previous part. 8 remains the denominator, but 3 becomes numerator. So we will write more there, 2 times 2t plus d. Now they are asking us to find displacement when t over 5 over 3 is equal to 5 over 6. To find the value of displacement, I will substitute the time in both cases. Let me do it here. So this s will be from 0, time is 0, till time when velocity, let me show here, when this is the situation, t to the power 5 third over 5 6. Let me find that t first, then I will go ahead. So t to the power 5 third equal to 5 sixth, and to find t I will get rid of this exponent 5 over third by its reciprocal. If I give 3/5 further and to the right side as well, this 5 third and 3/5 will cancel out. They multiply to 1. So t is 5 sixth to the power 3/5, and this is the time we will use from 0. Let me make more space here. 0 to 5 over 6 to the power 3/5. Okay, so let's do this. Okay, so this was our equation. We'll write it here. 6 times 3, 18 over 40. And I will substitute in place of t. I will give this time, which is 5 over 6 to the power 3/5. But this time has 8 third further. So I'll multiply this by further 8 third. Okay. And then plus 2t plus 2 same time 5 over 6 to the power 3/5 only, and plus d. Now if I substitute 0, this I have substituted already, this, because this time will become 0, this one will become 0, this will become 0, so d has no significance in that case also, so because d will subtract with d. So this is what we will get as an answer. So let me try to simplify. This will be 0.45, 18 divided by 40. This 3 and this 3 cancels, so 5 sixth over 8/5. Yeah, and then plus 2 5 sixth over 3/5, to the power 3/5. Just put this in a calculator and you will get the displacement, which will also be the distance. Let me use my calculator to do this, and by the time I do this, I would request you to kindly give this video a thumbs up, like it, share with your friends, and subscribe to Math United. We are more than 2K family now. What I'm getting here is 2.1288. There are more digits, so we can round it up to 2.13. And if this, yes, the unit is meters, so meters. I hope this is a little longer process, but I hope you got it. Okay, so let's go to question number 4, which says a ring of mass 4 kg is attached to one end of a light string. Okay, the ring is threaded on a fixed horizontal rod. Okay, so that means the weight of this ring will be 40 newtons downwards, because the mass is 4 kg. Okay, at 25 degrees it is down there below the horizontal with the tension T. The ring is in equilibrium. That is also again helpful information. Find in terms of T the horizontal and vertical components of the force exerted on the ring by the rod. Okay, so since the angle is here, this component will become T cos 25, and they said in terms of T. So this is there. 40 is already here, but there will be a component of this tension there as well. So it will be T sine 25 degrees. There will be, because this ring is not going down or going up, so that means there will be a reaction force or normal contact force which will balance these two forces. And there is a friction also. Yes, there is a friction as well, so there will be friction in this direction. Okay, so let's call it friction. Okay, but find in terms of T the horizontal and vertical components of the force exerted. So these are the horizontal and vertical components. These are the answer of part 1. Part 2. The coefficient of the friction between the ring and the rod is 0.4, given that it is in equilibrium, limiting equilibrium. So find the value of T. So we'll just make an equation and we'll get our solution. So friction will be, this horizontal component will be equal to this horizontal component, and they are already equal. So friction mu r will be equal to T cos 25 degrees. Mu is given, which is 0.4 r, because this r is balancing these two, so it will be 40 plus T sine 25, that is r, equal to T cos 25 degrees. So we'll get T now. 0.4 times 40 will be 16. 16. 0.4 times sine 25. Let me use my calculator for this. Will be 0.1690 T. So 0.4 multiplied by sine 25 is this, and T is T, this T. Okay, equal to cos 25 will be 0.9063, 0.9063, and T is T. We'll combine these two T's now. Which one is more? This is more. So let's bring this one to the right side. 16 equal to 0.9063 T minus 0.1690 T. 16 equal to 3 minus 0, 3, 7, 3, 7, 0. Okay, and T. So T will be 16 divided by 0.7373, and finally it is 21.7 newtons. So we got tension as well. So we found T and we wrote the components as well. So question number 4 completed. Let's go to question number 5. A block of mass 3 kg is tied with 2 kg, is tied with the ceiling. Okay, See diagram. Find the tension in S1. Only S1. Okay. And the tension in S2 as well. So for S1 we'll just focus on this part. Okay. There's no acceleration because it is steady. It is not moving as anywhere. So we'll just focus here. So if I make the free body diagram of this 3 kg, this will be the weight downwards, 10 times 330 newtons, and which will be stopped by S1, the tension in S1. Okay. Oh, let's call it T1. T1. Okay, so we can see that T1 is equal to 30 Newton. Similarly, this S2 is holding both of them and there is no mass to the S1. So T2 definitely will be the weight of this block plus this block, which is 5 times 10, 50 Newtons. There is nothing challenging here. The string S2 breaks. This one breaks. Okay. And the particles fall. The air resistance on A is, this is 0. On A 1.6 newtons and on B is 4 newtons. Okay. Find the acceleration of the particles and the tension in S1. So first let's take the whole system as one body first. That will help us to find acceleration. We know that net force is mass times acceleration, which is the applied force in the direction of motion minus the resistive force, right? Mass of both of them is 5 kilograms. Acceleration we want to find. Applied force will be the weights of 3 and 2, both, because it broke from here. So both of them are falling down. So 50 newtons is the force downwards, and resistive force we just got it, which is 5.6. 4, let me write here, 4 plus 1.6, they are the resistive force. There is nothing else which is resisting it. So acceleration will be 50 minus 5.6 divided by 5, this 5, which will be, let me use my calculator. By the time I do this, I'll request you to like this video, share with your friends, and subscribe to Math United. I got 8.88 meters per second square. So we found the acceleration, and now we have to find tension. So we'll again do the same thing. We'll focus only here with this one. What is the force downwards? 30. What is the force upwards? T1. But there is air resistance also, right? Newtons. Okay. 30 minus T plus 1.6. This is applied force for this small system. T plus 1.6 is equal to mass times acceleration. We got acceleration 8.88. So this same used only for this smaller part of the system. So 30 minus T minus 1.6 is equal to 4, 6 and 26.64. Okay, so 30 minus 1.6 will be 28.4. So minus T is equal to 26.64, and when these two, that's which is 28.4, will comes here, becomes negative 28.4, minus T equal to minus 1.76. So this cancels out. Tension T1 basically in this case is 1.6 newtons. T1 equal to 1.76 newtons. Okay, let's go to question number 6. A car of mass 1250 travels from the bottom or to the top of a straight hill. The hill is straight. We need to draw it. Okay, let me draw it here. Okay, mass is 1250 kg. Okay, has a length of 400 meters. That means this length is 400 meters. Okay, inclined to the horizontal an angle of alpha. So sine alpha equal to 0.125. That's what they've given, right? Okay. The resistance to car's motion is 800 Newton. Is going up, so the motion's resistance in this direction is 800 newtons. There is one more resistance here, which will be the component of its weight. What is the mass? 1250. So the weight will be 12500. So 12500 sine alpha. This is the component of weight in this direction apart from 800 newtons. So there are two resistive forces. Find the work done by the car's engine. So car's engine is pulling it up. So it will be the applied force by the engine. In each of the following cases, there are two different cases. Okay, so let's make two cases. First, the car's speed is constant. When is the car's speed constant? When acceleration is 0, because there is no difference in velocity. If velocity is not changing, acceleration is equal to 0. That means F net we talked about earlier, which is equal to mass times acceleration, is also 0, right? Which means, because our formula is mass times acceleration, F net is equal to applied force minus resistive force. Since this thing is 0, applied force becomes equal to resistive force. So whatever is the sum of these two will be the applied force, right? So they are asking find the work done by that applied force. Okay, so first let's write what is applied force. So it will be the sum of these two, whatever is the resistive force. So 800 plus 12500 sine alpha is given 0.125. These are the forces. And if we want to find the work done by the applied force, that's what they're saying, right? Work done in car's engine will be applied force multiplied by the distance it takes, right? The angle, there is cos theta also, which we did in question number 1, but there is no angle between the applied force and the motion. Both are in the same direction. The angle is 0, the cos 0 is 1, so we don't add cos here. So we have applied force 800 plus 12500 times 0.125. These are applied force. Further we'll multiply by distance, which is 400 meters. It went from bottom to the top, and whatever that gives you is the answer. By the time I calculate this out, request you to like this video, share with your friends, and subscribe to Math United. What I'm getting here is 945,000 joules, or you can write 945 kilojoules. Okay, 1000 means kilo. All right, let's go to second part. The cars in, so this situation, second situation, is different from the first situation. So forget what we did here. Okay, this is a different situation. That's what they're saying. Following cases, the car's initial speed is 6 meters per second. So here at the bottom, u is 6 meters per second. The car's driving force is 3 times greater at the top of the hill than it is at the bottom. Okay, so if car's driving force, the force applied, let's call it F only, is something, it will be 3 times here. Okay, now car's power output is 5 times greater at the top. So if P is here, it will be 5 times P at the top. Okay, so now we have to find what is the work done by applied force. Okay, So we'll use the energy formula in this one, which is the applied force. The work done by applied force is the work done against resistance plus change in kinetic energy plus change in potential energy. Okay, so work done against resistance. Resistance is how much? 800 still, 800 newtons. So 800 force times distance, right? Force times distance. In this case it was applied, but in case of resistance it will be resistance 400. Okay, change in kinetic energy will be half m mass multiplied by the square of the velocity, final velocity. Okay, what is final velocity? We don't know. Okay, that is the problem now. So we'll have to find velocity. Power is the force multiplied by speed at a moment. At this moment the speed is given as 6. So power is P, F is F, and speed is 6. So we can, what do we want to use here? Force, right? So we can use power here, isolate power. Power is 6F. So when we reached here, right, we want to say that 5P is equal to F, which is 3F in this case, times V, right? Whatever is velocity here. And we'll substitute the value of P, which was down there, in this equation. So 5 times 6F, yeah, F times 6 is 6F, equal to 3F times V. So F are on both sides multiplying, we can cancel them. So what do we get? 30, 6 times 5, 30, equal to 3V. And V we got as 10 meters per second. 30 divided by 3 will be 10 meters per second. So we got the V here, it is 10. The final velocity. What was the initial velocity? 6, we already knew. So we got delta KE, change in kinetic energy also. Now delta PE, which is change in potential energy, which is M1250 G. We'll add one more 0. And height. How much height has it gained from here to here? So let's call it H, and I will find it here. H divided by 400, which is this 400, will be sine alpha, isn't it? So H becomes 400 sine alpha, right? Sine alpha is also given to us, so we'll just write here. So H, final height is 400 sine alpha, and the height earlier was 0, it was at the bottom, minus 0. So if you don't know these formula, let me write them here. Delta KE always equal to half m final velocity square minus initial velocity square. Delta delta PE, potential energy, is equal to mg and final velocity final height minus initial height. Now that's what I've done here. Change in kinetic energy, change in potential energy. All right. So this comes okay. We can use calculator for this, but as much I can do with mental math, I will do it. So this will be 625. 100 minus 36 will be 64 plus, and this was already done here, if you remember. Yeah, it's change this thing again. So I can write it 12500 sine alpha 0.125 and 400 was also there, right? 400s and 0.125. Yeah, this is what I will put in my calculator and I should get the answer. By the time I do this, I again request you to please like the video and share with your friends. What I'm getting here is 985000 or 985 kilojoules. Little more than what we got earlier. What next? Question number 7, the last one. Okay. The frictional force acting on a small block of mass 0.15 kg, the mass of this block is 0.15 kg, while it is moving on a horizontal surface has magnitude of 0.12 newtons. So there is a friction 0.12 newton if it is moving this way. Okay, the block is set in motion from point X on surface 3 meters per second is the velocity here. Okay, they've written here. It hits a vertical wall Y on surface 2 seconds later. So time is 2 seconds till it reaches Y from X. The block rebounds from the wall. Okay, it goes there and rebounds. Okay, and point Z stops here. So V equal to 0 here. Stops, right? Comes to rest at Z. At this instant that the block hits the wall, it loses 0.07. Okay, so delta KE, change in kinetic energy, is minus 0.72 joules because they said loses, so we'll say minus. The velocity of the block in the direction of from X to Y is V meter per second when it is going in this direction after it leaves X. Find the values of V when block arrives at Y here. Okay, and when it leaves Y. Okay, find also the value of T when the block comes to rest. So three things we have to find: V when it reaches here, V when it goes towards Z, and the time it takes to reach. Okay, and we have to sketch velocity time. Too many things. Okay, so let's start with the first thing, the velocity when blocks arrives at Y. So part 1, V is equal to U plus AT. V we want to know, U we know 3, acceleration is not known to us, but time is known to us, 2 seconds. Now acceleration is the problem. When this block is going this way, there is nothing, no force which is being applied on it. It is just being, it was pushed and now it is going on its own. So applied force is 0. But there is a resistive force of 0.12 Newton. So we know MA is equal to F applied minus resistive force. Mass of this is 0.15. Applied force is 0 and resistive force is 0.12, and we didn't multiply with acceleration here. Okay, so acceleration is minus 0.12 divided by 0.15, which is negative 4/5, 3 times 4, yeah, 0.8 meters per second square. This is what we will use here, minus 0.8. So V comes out to be 3 minus 1.6, which is 1.4 meters per second. Okay, first part done. And when it leaves Y, it loses kinetic energy, right? So we'll use kinetic energy in this part, which is delta KE, which we used in previous question also, which is half m final velocity minus initial velocity, right? So it is minus 0.072 equal to half 0.15 v square. We don't know, because after rebounding, what is the velocity? That's what they're asking. But before that, we just got how much is the velocity, which is 1.4. V is the only unknown thing here. So I'll just first multiply this here. So minus, let me make more space here, minus 0.144. This 2 has been taken care of. 0.15 still there. V square minus 1.96 is the square of 1.4. So let's multiply these two. Okay, So minus 0.144 equal to 0.15 v square or minus 1.96 times 0.15. This negative will become positive when it goes to the other side. So 1.96 times 0.15 minus 1.44 equal to 0.15 v square. And let's leave v square here and divide the solution of this one. 0.15 minus 1.44, not 1.44, I made a mistake here. It was 0.144. So 0.144 equal to 0.15. Let me give it a number, rather we can square root straight away. The whole of it, you can put in a calculator. Since we have the luxury of using calculator, we can do this. By the time I do this, I would request you to like this video, share this with your friends, and subscribe to Math United. What I'm getting here is just 1 meters per second, and that makes sense, right? When it reached at y, the speed was 1.4 meter per second. It lost kinetic energy, it became slower, and it came with 1 meters per second towards x. Okay, the second one is also done. And find also the value of t when it comes to rest. Okay, so that will be easier part, I think. So now we know that v equal to u plus at, which we used earlier. At z, it is coming at rest, so v is 0 in that case. When it started from this wall, its speed was 1 meter per second, which we just got in previous part. Acceleration is already same thing because the surface is same. It will remain what it was, minus 0.8 meters per second, and they're asking us the time. Okay, so do we know anything? Otherwise, which is equal to 1 minus 0.8, t is 0, 0.8 t will become positive when it goes to this side, equal to 1. Okay, so time will be 1 divided by 0.8, which is how much? 1.25. Yeah, because 10 divided by 8 is 1.25 seconds. So 1.25 seconds later, it reached z and stopped. Finally, we have to sketch the velocity time graph for this. I will try to draw it as good as possible. I'll draw it freehand, but in your exams, you need to be very careful about this. So this is t, this is v. Let's say this is 1, this is 2, this is 3, and this is 4. So velocity at t equal to 0 was how much? It did not start from rest, it started from 3 meters per second square. So we need 3 also. So we'll write 1, 2, 3, and the unit is meters per second. Here the unit is seconds. So 3, it started at 3 meters per second here. Then it decelerated. That means the gradient of this will be constant for 2 seconds. And the speed became 1.4, which is 1.4 will be somewhere here, right? This is the first 2 seconds, right? This is 2 seconds. Now, suddenly after 2 seconds, the speed became 1 meter per second, but in opposite direction. That means I need a negative also. So this is negative 1 meter per second, right? So your graph will start from here now. Okay, negative 1 meter per second, and add 3.25 because 2 seconds and then 1.25 seconds later it reached here z. So 3.25, if it is here, it slowed down. It was 1 meter per second in opposite direction, went and became 0 meter per second at z 3.25. This is 3.25 seconds. This will be the VT graph for this particular happening. Okay. Part 2, the displacement of the block from x in the direction. Okay, so we have to find, let me see what is it here. Okay, find the values. In the direction of x and y is s meters at the time of t second. Sketch the displacement time graph. Show on your graph the values of s and t. That means we have to get this displacement also, block y, and when it comes to rest to z. Okay, so let me try to draw another graph which is s and t. Okay, s is in meters, t is in seconds. Okay, but we need to know values before, but we know time. Okay, 1, 2, 3, and there will be 3.25 here somewhere. Okay, so first, how much displacement took place between x and y? So we'll use this formula, s equal to ut plus half at square. We know everything. S is u. It started with 3 meters per second. Time it took to reach y was 2 seconds plus half. There was acceleration 0.8 and then 2 square again. So we can cancel this 2 and this. So it is 6 minus 1.6, which is 4.4 meters. So s is 4.4 meters in first 2 seconds. So because displacement will reduce later, so it is okay. 1, 2, 3, 4 and 5. 4.4 will be somewhere here in 2 seconds. So it will reach here. Okay, 4 point, no, not here, little up, 4.4 meters. Okay, but the velocity was changing. That means the gradient of this will change, and it was very fast, 3 meters per second, and then it became 1.4 meter. So that means the gradient will reduce. So the gradient will be steeper first and then it will reduce. It will not become 0. Okay, I'm not giving it a look that it becomes, because it was 1.4 meters here. So at 2 seconds it will be still having some gradient, but less than this 3 meters. Okay, then in return journey I'll use the same formula again, s equal to ut plus half at square. So let me write here s, which is, we don't know, u. This time when it was rebounding, its speed was -1, but since I want the displacement, so I'll use 1 because I want total displacement. I know the direction will be in this direction, right, because it's going back. So I'll use 1. Time is 1.25 seconds, right? In 1.25 seconds, ut plus half, resistance still 0.8 and 1.25 square. Okay, so let me do it here. 1.25, 0.4 and this. So let me do it with the calculator now. By the time I'm doing this, I would request you again to subscribe to my channel and like this video. Okay, 1.25 square, 0.625, so minus 0.625. okay, with 0.625 meters. So that means from 4.4 it will come down 0.625, which is 3.775. Here 3.775. So you can write S equal to 4.4 here, because they have said clearly show how much displacement is there, and it will reach here. But again, it will be a sharp, it will not be a smooth turn, it will be a sharp turn, because again suddenly it has -1 in negative direction, and 3.25 will be here, it will reach 3.775 here. So our graph will be steeper because it's coming back at 1 meter per second, and then it is becoming 0. So it will be steeper, but not as steep as this, is because this, the gradient of this one is 1.4 meter per second. Gradient with this will be 1, but it will go at a lower gradient and become 0. It has become a line, so I'll have to undo this. Okay, like this. So it will go there and become, gradient will become 0 finally, because the gradient of ST graph is the velocity. And this concludes our ST graph for this question, and that also concludes this solution video. I request you to like this video, share with your friends, and definitely subscribe to Math United to get such more videos in future too. I answer the latest ones as well as some old ones. So thank you very much for your attention.